All right, so guys, here we go. So we are section 4, solving quadratic equations using square roots. Remember, not every quadratic equation can be solved using a square root. You are only able to solve quadratic equations that do not have a bx term. If there is no bx term, you will be able to solve that using square roots. So I copied the steps again for you. When we solve something using a square root, your first job is to get whoever is being squared completely by itself. So either x will be squared, and your job is to get x squared by itself, or some quantity, some parenthesis will be squared, and your job is to get that quantity all by itself on one side. Once you get whatever is being squared by itself, you can unsquare it by taking the square root of both sides. But don't forget, when you unsquare a square, there were two possible answers that could have gotten you that. So then you have to use your plus or minus sign to show that there are two versions of that answer, because we should be getting two answers to a quadratic equation. And then you always simplify your answer. We always simplify fractions. And now we also always simplify square roots. We never leave a square root that is not simplified. We also do not leave a square root in the denominator of a fraction. We times it by itself, and we do something called rationalizing the denominator. All right, here we go. Let's try number 1. So if we have to solve these equations using square roots, first of all, in number 1, notice what is being squared. It's not x who's being squared, it's a quantity. It is this entire parenthesis that is being squared. So your job should be to get that alone. So the 72 and the -2, they can't be here. They have to go to the other side. So who do you move away first? The 72 that's not attached, or the -2 that is attached? 72. Always move what's not attached away first, because it has nothing to do with that parenthesis right now. So we'll minus it to cancel it out and move it over here. Now we have -2 times the quantity x minus 7 squared equals -72. Now be careful, because a lot of times when you have a number attached to a parenthesis, you have been trained to get rid of those parentheses by distribution. But guys, this parenthesis is being squared. So PEMDAS says you have to square this before you're allowed to multiply. So you have no option of distributing here. The only way to get -2 away is to do what? What's going to undo that multiplication? Divide. You have to divide it away. So we divide both sides by -2, and then you are left with the quantity x minus 7 squared equals positive 36. So guys, you did it. You got what is being squared completely by itself. Now you need to unsquare it. Well, what unsquares something in math? A square root. So we're going to square root both sides. What does a square root do to that square? Cancels it, just leaves you with x minus 7 equals. Now guys, the minute you take the square root of both sides and you unsquare something that was squared, how many versions of this answer do you create? 2, the positive and the negative version. So plus or minus. And now notice, what is the square root of 36? It's a perfect square. You can take the square root of 36 and get 6. No more square root. So now you have that. So the square root went away. That's a great thing. The problem is our job is to solve for x. X isn't alone yet, so we have to keep going. So what would you normally do to continue to get x alone? Add 7, right? Nice and easy. But now it kind of gets weird. You're like, wait a minute. If I add 7 to this side, who am I adding 7 to? Because that's not 6. That's plus or minus 6. It's 2 numbers in 1. So I told you guys last week. Does anybody remember where I told you to shove it? I told you to shove it right in front of the plus or minus sign. And I say shove it on purpose, hoping you'll think, hey, she just told me to shove it. Yeah, I want you to put it right in front of the plus or minus sign. So now the problem says this. X will equal, 7 goes in front, whatever 7 plus or minus 6 is. Well, guys, look at this statement. The directions are always going to say simplify. We're not done because we can simplify this. This is not a square root. This is 6. I can take 7 and add it with 6 and get a number, and I can take 7 and subtract it with 6 and get a number. So we're going to play both of those scenarios out because there's no square root anywhere stopping me from adding and subtracting these two things together. And it's a quadratic equation, right? So I should get 2 answers. So one answer, x will be equal to whatever 7 plus 6 is. What's 7 plus 6? So 13 is one answer to my degree 2 equation. And then the other answer will come from whatever x is equal to when you take 7 and you subtract 6 from it. What's 7 subtract 6? 1. And that's your second answer. So you are allowed to do the plus or minus when this is not a square root. It's 7 plus or minus 6. Do that. Do 7 plus 6. Do 7 minus 6 and get your 2 answers. Does that make sense, Bianca? So that's when you're going to be able to add and subtract them. If you put this in, you could be like, well, hard to understand. That is the answer. And you're right. But because they put the word simplify on everything, this is not a simplified answer. You can do both of that adding and subtracting out and get a simplified answer. All right, so that's one way. That's how one answer is going to happen. This is like best case scenario. This is the nicest it's ever going to play out. All right, let's look at example 2. Same thing. Our job is to solve this using square roots, right? So you want to get whoever is being squared completely alone. Well, guys, this problem's different because now only x is being squared. It's not the entire parenthesis that's being squared. So if you wanted to distribute, combine like terms, have at it. You're allowed to do that. Or to try and save you that distribution that you'll probably have to undo a little bit at some point. Right now, negative 9 has nothing to do with that parenthesis. So how could you get it away right now? I can add it, cancel it out, and add it to the other side. And now I have negative 3 times x squared plus 5 equals negative 69. And again, if you wanted to, you could distribute the negative 3 right now. There's nothing stopping you. This parenthesis is not squared. I am allowed to distribute. Or we could do what we did over here. Instead of distributing to get rid of those parentheses, I could undo timesing by negative 3 by doing what? I could divide it away. I could also divide it away and be done with it that way. And now I don't need my parentheses anymore because there's nothing to multiply it with. It's x squared plus 5 equals, what is that, 23, okay? And now we're almost there. Keep going. Kayla, you haven't put it down yet. All right, so now we have to get x squared by itself. Some of the biggest mistakes students make is they know they have to square root. Don't square root too early. You can't take the square root until whatever is being squared is alone, and he's not alone yet. So how do I get 5? Because 5 isn't being squared away. Subtract it. And now you get x squared equals 18. So we did it. We got what is being squared alone. Now we go to unsquare it by doing what to both sides? Square root. Now the square and the square root will cancel. X will equal. The minute you take the square root of both sides and you unsquare a square, how many versions of the answer are you creating? 2, plus or minus. And now ask yourself, can you take the square root of 18 and get a whole number back? No, right? Because you can take the square root of 16 and get 4, and the square root of 25 and get 5, so the square root of 18 must be 4 point something. And we don't want decimals. We don't want to round our answers. We want exact, simplified answers. So what I do now is I take the square root of 18 off to the side, and he's either going to stay the square root of 18 because he's a simplified square root, or he's going to simplify. So ask yourself, is there a number that you can take a square root of that divides evenly into 18? 9. So we're going to break him up into the square root of 9 times the square root of who? Who's the leftover? 2. And now what is the square root of 9? 3. And then the square root of 2 stays because he is a simplified square root. There's no number, besides 1 doesn't count, that I can take the square root of that divides evenly into 2. So he simplifies to 3 times the square root of 2. So that's what you're going to put as your simplified answer. It is plus or minus 3 times the square root of 2. Which, guys, if you ask your calculator, 3 times the square root of 2 and hit enter, it's 4.242640687, and it only stops because my calculator stopped. This is an irrational number. It is a decimal that never ends and never repeats. It's the worst answer in math. So I don't want you to write it, which is why we leave it like this instead of estimating a decimal. Go ahead.
Isn't that where you put like the line in front of the...
Where's it again?
Isn't that where you put like a line in front of the decimal number, like the ending one? So like indicates it keeps going?
No, well, sometimes like let's say if it was 1.4 repeating, we'd put a bar over the 4, but that's only because 4 repeats. In this case, I couldn't do it because this decimal doesn't repeat. It doesn't end, it doesn't repeat, it's an irrational number. It's the worst possible number in math. Go ahead, Darian.
Did you put 6 and 3 to
Okay, the problem is, let's say you did 6 and 3. Can you take the square root of 6 and get a whole number? So that didn't do anything for you. Can you take the square root of 3 and get a whole number? So it didn't do anything for you. You picked two numbers that you can't take a square root of. So now that's why we picked 9, because I can take the square root of 9. Now, Damon, if you go this route, you're going down the route of prime factorization. Now they're going to make you break 6 up into the square root of 2 times the square root of 3 times the square root of 3 comes down. Now, these are all primes. They only have factors between 1 and themselves. So now you're going to have the square root of 2 stays. What's the square root of 3 times the square root of 3? The square root of 9. And what's the square root of 9? 3. So you still get the same answer, but you're going to work a lot harder for it. That's why you want to pick numbers that you can take the square root of. Okay? All right. And you should notice, the minute you break it up, you're like, wait a minute, that didn't work and that didn't work. So get rid of them. Find a number you can take a square root of. All right, so now you can type this into Delta Math as 2 answers. Or you can break them up and say one answer is when x is equal to 3 times the square root of 2, which like I said is like 4.24 blah, blah, blah. And the other answer is when negative 3 times the square root of 2, which is like negative 4.24 blah, blah, blah. The answers to this equation are just very ugly decimals, and we don't want that. We want the exact simplified answers, which is the simplified square root. Okay? Is everybody okay? And guys, these are the x-intercepts. This parabola would have crossed over the x-axis when x is 13 and when x is 1. This parabola will cross over the x-axis when x is 4.24 blah, 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 and when x is negative 4.24 blah, blah, blah. It's just he crosses over at very ugly decimal points. Okay? All right, one more and we're done. Just want to give you a little bit of how weird these answers can start to get. All right, last one. Notice, it's another one where it's not x who's being squared, it's a quantity. It's an entire parenthesis that is being squared. So your job is to get that parenthesis by itself. So this 2 and that negative 4, they can't be there. So what are you going to move away first? Add the 4, cancel it out, move it to the other side. All right, so now we have 2 times the quantity 5x minus 1 squared equals 66. You do not have the option of distributing that 2 to get rid of those parentheses because these parentheses are squared, and PEMDAS clearly says we would have to square this before we times by 2. So you are not allowed to times by 2. So how do I get rid of timesing by 2 if I'm not allowed to? Divide. All right, and now we're going to get the quantity 5x minus 1 squared equals 33. So you did it. You got what is being squared completely by itself. Now, how do you unsquare it? Square root both sides. The square root and the square cancel. You are now left with 5x. I'm still on the camera. 5x minus 1 equals. Can you, now, hold on. The minute you take the square root of both sides and you take the square root of a square, how many answers are you creating? So plus or minus. Now, can you take the square root of 33 and get a whole number? No. Does he simplify? Can you think of a number that you can take the square root of 4, 9, 16, 25, 36? Do any of them divide evenly into 33? Then he is a simplified square root, and he gets to say the square root of 33. That is less work for you. He's already simplified. You can't take his square root, but you can leave it. Well, I mean, obviously you can take it. It's just a decimal. I don't want you to take it. All right. Now, here's where it starts to get really weird. So you have this plus or minus the square root of 33, right? And you ain't done yet. You haven't solved it for x. X is not alone. So keep going through the motions. What are you going to do next to get x by itself? Add 1 like normal. But then it's like, wait a minute. Add 1. Who the heck am I adding 1 to? You can't add it to the 33. He's under a square root and 1 isn't. So where did I tell you to shove it? In front of the plus or minus sign. So 5x is equal to 1 plus or minus the square root of 33. Guys, the square root of 33 is like 5.7 something probably. It's a very ugly decimal, and I don't want you to use it. So leave it as the square root of 33. And now what is the only thing you have left to do to get x by itself? Divide by 5, and then divide this by 5. And x is equal to, as weird as this is, 1 plus or minus the square root of 33, all divided by 5. Now, I could have divided 1 by his own 5 and divided plus or minus 33 by his own 5. I could have split them into 2 separate fractions. But because 1 doesn't divide by 5 and the square root of 33 doesn't divide by 5 and nothing reduces, I just chose to leave it like that. So guys, that is your 2 answers to this degree 2 quadratic equation. And if you want to see them separate, one answer is when you take 1 and you add it with the square root of 33. Guys, it's a really ugly decimal. 1 plus the square root of 33 is 6.744566, 62647, blah, 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 it goes on. And then you have to divide it by 5, which is now making your first answer 1.3489125529, blah, blah. We don't want that. I don't want the decimal. So that is as exact and simplified of an answer as you can give me. And then the second answer is when you take 1 and subtract the square root of 33, which is negative 4.74456267, blah, 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 and then divide it by 5, and you get negative 0.9489125529, and so on. I don't want those answers. So these are your 2 answers written as 1, or these are your 2 separate answers, and Delta Math will let you type them in either way. Type this in as 1 answer, or type these into 2 separate answer boxes. It does not make you put the X equals. They have it on their keyboard. If you look at Delta Math, it has a plus or minus button for you. Otherwise, our keyboards don't have it. Okay, that's why they give you one on Delta Math. All right, so guys, the answers aren't going to be pretty. Factoring gets you the nicest answers to a quadratic. But not all quadratic equations factor. Not all quadratic equations have these beautiful solutions. Some of their solutions are just ugly numbers. So square roots, and then when we do this last method, the quadratic formula, answers are going to start to look like this, and it's just not pretty. But those are the answers, and those are the exact simplified answers. Okay, tomorrow I'm going to continue in section 4, but I'm only going to get tomorrow, and then Monday is testing. Tomorrow I want to do part 2 of section 4. I'm going to introduce something to you that I know you've never seen before. We're going to be introduced to imaginary numbers tomorrow, all right? So it's going to take a turn for the crazy, if you will. All right, I did create an assignment today on Delta Math to help you practice this again. You can work on that right now. You can work on an assignment that you maybe missed while I was out. But this assignment from today is due tomorrow night, like a normal homework assignment at 11:45 at night tomorrow. I didn't post anything on Google Classroom yet. I'll try and do that after school today, but there is an assignment today.